So,
The opposite side.
The opposite side, okay. But let's go back and read it and then look at your pictures. So if you read it, it says, if two sides of one triangle are congruent to two sides of another triangle, and the included angle in one triangle. So what's that mean? What's an included angle? Exactly right. So what they're saying is this. Right? They're saying that this side is congruent to that side. And this side right here is congruent to that side. Okay? That's what those words said. The included angle then would be angle 1 here and angle 2 there. Everybody agree? So if they're saying that angle 2 is, instead of writing a little 2, we're going to say that this angle is, how much do you think that is?
45.
Okay. Probably more than that, but whatever. 45. This one over here, smaller or bigger? Smaller. 37 degrees. Okay? So what the hinge theorem said, or side angle side says, is if this angle that's in between those congruent sides is bigger than this, then what's true about this side and this side? This side that is opposite of the 45 has to be bigger than that side that's opposite of the 37. So here is, give me your letters again that you said. EF was bigger or smaller? EF, oops, sorry. EF, B, C. So then we would say that EF is greater than BC because of that theorem. Does that make sense? And then in the other one, they would say this, in the converse, what's the converse mean again? Flip it, right? So basically, this is saying if two sides in one triangle are congruent to two sides of another triangle and the third side of the triangle, so now they're basically saying just the opposite. So the converse of this is the same concept, that those two things are still congruent to each other. But instead of giving the angles, then they're going to give you the lengths of the sides. So this one's 12 and this one's 15. Then the opposite is also true. So we can go back to those angles. And because 15 is longer than 12, it means that this angle 1 is greater than angle 2. That makes sense? Okay. So the first one is giving you the two congruent sides with the angles, and then you're talking about the sides. The converse is giving you all the sides, and then it's going back to comparing the angles. Make sense? Now does this kind of click for some of you? Except for Candy, because she's used to being whatever she's saying. All right, so good there? So remember now, we're going to look at the range. This is when you're always going to talk about the range is always going to be where it could be in between of, correct? The biggest and the smallest, okay? So we either have the range that is talking about the angles, or we have the range that is talking about the sides. Remember all this that we wrote down? You should have all this written down, right? Okay? So, what did we talk about in the range in your notes? For the theorem, okay? So, you're going to look at the information and you're going to write the first one. If it's less than, remember, you have two options. If it's less than, the other one has to be greater than. Remember that? And when we talked about angles, if the first one is less than, the other one has to be greater than, and it has to be greater than what? 0. It's got to be greater than 0. If the original one is greater than, the second one has to be less than 180. Why? because all three of my angles in a triangle have to be equal to 180. Okay? What about my sides? My sides, we're only caring about if it's greater than what? What does the length have to be? Not negative, so it has to be greater than 0. Okay? So this is the one we probably need to look at examples of. All right? But again, you should have all of that in your notes also. So let's go back to this. That's not going on. Yes, it is. We're going to. That's probably one of the most confusing things I ever went through. What we did earlier. So you remember this?
Sure.
Did we get to these examples ever? Do you remember that? You only have 2 examples? Big boy, you need to move a little bit. Slide in there more. Can you slide in there? Oh boy. Alright, so first things first, we gotta find side angle side. Do I have 2 congruent sides in my triangles? Yes, because what is my second congruent side that they don't really show us? DC. Why is DC congruent to itself? The reflection property. Remember all that? So, if I then looked at, so basically we have side, angle, we're talking about those angles, and then here's my second side. So we have SAS. Now we're comparing these lengths. So which one's bigger, AD or BD? AD, because why? 70 is bigger than 68, right? So that means if this angle is bigger, this length has to also be bigger. That makes sense? Okay. Obviously, we can have different kind of triangles and such. So now they're saying compare angle ABD. So is this angle right here or is this angle right here bigger? What do you think? This angle right here or this angle right here? Is ABD or BDC bigger? Because 5.5 is bigger than 5. That makes sense to everybody? So, here's my range one. So, this is, again, where we went back and we said you always want to make sure that you take the quantity angle. The quantity angle is the one that has an algebra problem in it. So in this example right here, 9a plus 15. We always want to start with that. Okay? So we would write 9a plus 15 is what compared to 141? 9a plus 15, you said, is less than 141. Does everybody agree? Everybody see why? Why again? Because 18 is greater than 16, right? Okay, so if this is my first part, the second part, so again, what are we talking about here? These are representing angles, right? 141 is an angle and this is an angle. We just don't know what it is yet. But they're both angles. So if the first one's less than, the second one has to be greater than, and in a triangle, it still has to be greater than what? 0. So my second one, I'm always going to use the quantity. So put 9a plus 15 is greater than 0. And this is what I would use to find my range. So if I did this now I'm ready to solve. How do I get a by itself? Subtract 15. 141 minus 15. How do I get a? 126 divided by 9. 14. Now do it over here. 9a is greater than negative 15. A is greater than, if I reduce, Take 3 out of both of those, I get 5/3. Now here's the question. Can I have negative in my range? Now we talked about that we could never have negative because it has to be bigger than 0, right? But is this actually showing us that it's 0? Or that's that angle? Not necessarily, because if I take this number right here, give me an A that is bigger than negative 5/3. 1, 0, all of those. If I put 0 into this equation right here, do I get a positive answer? Because when I put 0 here, it cancels it out, and I get 15 is greater than 0. Is that true? Yeah. So even though my A happens to be negative, it doesn't mean that my answer is wrong necessarily. I just can't get an angle that can be negative. So the actual variable can be bigger than, or can be actually negative. So what's my range? My range is A has to be greater than negative 5/3 and less than 14. If I pick any number inside of there, it should make both of my inequalities a true statement. Okay? But does everybody see how we built those inequalities and why we got them? Yep. Okay. So again, the most important part of this is always starting out with the quantity part. Right? The part that has the variable first. And the first one always comes from the inequalities, or sorry, not the inequalities. Well, kind of. But the theorems of the inequalities that we got from our figures. And then the second one just depends on what we're talking about. Okay? So, let's try to find it. So here's my next one. So just think about this one by yourself for a second. And what inequalities could I make from this? So the first one again goes or comes from the angles or the quantity that we're talking about. So my first inequality is going to be what?
7n plus 5 is greater than 47.
7n plus 5 is greater than 47. Everybody agree? Why did John say that? Because again, if I look diagonal from both of my angles, 11 is bigger than 9. Everybody agree with that? So again, if the first one is greater than, the second one, again, I use the same quantity. It has to be the opposite, so it's going to be less than, and it has to be a less than what? 180 this time. So notice the difference. If the first one is less than, the second one is greater than 0. If the first one is greater than, the second one is less than 180. And again, that's because of the 3 angles in the triangle. Everybody agree with that? And then all you got to do is solve again. Okay? So how do I get n by itself? Subtract 5. N is greater than 6. Subtract 5. N is less than 25. So my answer is n is less than 25 and greater than 6. And that's my range. So again, I should be able to pick any n inside of there, and it should make both of my inequalities true. If I would pick something like 26, and I would stick it into my inequalities, it wouldn't make it true. Make sense? Now again, here's where you got to think. So the angles are easy. The sides, you might not have a true range. Because the only thing that I care about again is what? That my sides are what? Positive. Okay, so if the first side, it says that we write 2x plus 3 is greater than 6, for instance. I'm just making this up. But notice that it's already greater than, so it has to be positive, right? It's greater than 6. Any number that I pick bigger than 6 would be a positive number. Would you agree with that? That's the only one that I have to do. I don't have to have a less than part then on my sides. But if the first problem is 2x plus 3 is less than 6, then I have to also say 2x plus 3 has to be greater than what? It's got to be greater than 0 because I want it to be positive. So does that make sense? Sometimes when you're dealing with the sides, you're only going to have one part of the inequality. So then this answer right here, subtract 3 would be what? X is greater than 3/2. This would be my entire answer. I wouldn't actually have an inequality that showed a range. Does that make sense what I'm saying there? The bad thing is, I think we have to go to the book if you want an example of this kind. So, you want to see one with the sides? Yeah. So, turn your book to page 376, and we're going to look at number 7. Up in the problems up top, we'll look at number 7. So, notice this one right here. Do I have side angle side? Yes, I still have my pinks and then my angles in the middle and then my shared side right down the diamond. So, what inequality can I write? Now, this is the one where it's a little bit confusing anyway, because if I looked at this right here, I need to make sure, I see both sides that are given to me have inequalities in them. You see what I'm saying there? One is 3x minus 5, the other is 2x plus 3. So it's not like our other problem where they were just, one of them had a number and one of them had a quantity. This one has both. So realistically, I'm just going to make my answer and pick one of the two. I don't think it really matters. But remember right. So if I looked at this right here, I want to say that 3x minus 5 is what to the other quantity? Less than how much? What's the other quantity, sorry? 2x plus 3. And if it's less than, then the other one has to be 3x minus 5 has to be greater than what? Still has to be greater than 0, right? Because I always have to have positive numbers. And then I'm just going to go through and solve the problems again. So, combine my x's. Which way should I take my x's? To the left or to the right? To the left, because we want them positive, right? So we subtract 2x, and that means we're going to add 5. If I add 5 to this side, I get x is less than 8. Agreed? What about this one? Add 5 and divide by 3. So my two answers are x is greater than 5/3 and less than 8. And then I would get my range still. But again, we're only talking about x, so realistically you would take that x and you would put it back in, and it would prove that the inequalities are then true. So again, what's 5/3? What? 1 2/3. So if I pick a number bigger than that but less than 8, and stick them both into my inequalities, they should both work. Because it.
Mr. Carnizel,
Yeah.
could you have Lauren come to the office, please?
She's on her way. All right. So, two theorems, and then the range. Most important part of the range is always starting with that part that has the variable. Okay? So, I apologize for being so confusing at the beginning.